Hi everybody, thanks for watching again. This video doing jumper cables. So my last video track cleaning, well the one before my last video track cleaning and tightening rails up and stuff like that. So you can see I've cleaned them rails on this piece of sport track. Used to be a lap counter, but I've took all stuff off at back. Took all electrics off it. So that's just standard board. So what we're going to do is we're going to use these little tags here. Use them tags to solder cables to. Drop them down the baseboard and then send it full length at layout. Because then in a few joints time, we'll drop another one of these boards down and pick jumper cables up. So what we do is we've got 4 colours, and these four colours are blue and yellow, orange and green. So these colours I've got here not totally independent from my lighting colours. So my lighting colours are red, brown and white, and then from my jumper cables are red and black. So I've picked these 4 colours, so there's no way, when you look under the layout, there's no way of seeing that it's a lighting system. It's a totally separate circuit. So I've drilled my holes. I'm just going to drop my wires through. This is 18 AWG wire, silicone wire. So I'm going to do yellow and blue on one side, and then green and orange on the other side. I've got 2 meters of cable, but this is only to link to my main cables from each piece. Now this will be sufficient enough. This will be definitely thick enough to carry power from the track to another piece of track. So that's lane 1 and 2 goes in that way. So to get them wired in properly, if you flip it that way, if you flip your track that way to wire it, you can lose which lane it is. So like the inside and the outside, this is lane 2 and that's lane 1 because you flipped it over. So it swaps your lanes over. But if you flick it that way, then it stays the same. This is lane 1, that's lane 2. So I'm going to solder this blue wire onto I've drilled my holes in my baseboard to correspond with these tags. With these tags here. This tag and this tag. So my outside wire is going to be yellow. It's going to be blue, and then the inside lane's going to be yellow, and then I'll do the wiring colours on the other side. In fact, I might change them round. Well, I'll connect my track up, my power base up, and I'll show you the what I was saying about voltages in my other video. So I'll go over it again. So your power track, your Art Pro on digital, your track's live all the time. And when your track's live all the time, that's why I can get your lights to light up on digital, because your track's live all the time. On analog, it's not. Analog's only got power to track when you pull your controller, when you pull your trigger. Digital, it's constantly live. and I'll show you what I mean. So these are my two, because my layout's quite big. I've got two power supplies. On the ArcPro system you can have two power supplies. So that's because you're having 6 cars on track and racing with crossovers, you need that extra power, just a few extra amps to you work all your power straights and stuff. So you set your test meter 20 volts, that's DC. This line here, that's DC because it's straight, the lines are straight. This AC, this volts with a squiggly line, that's AC, that's alternating current. All your scalextric track and everything all works off DC. So that's turned on, it's on digital. You can see my lights work on my light bobbin. So you put your test meter prongs on your track, and you don't get any power on it. That's 200 millivolts. That's how small a voltage it is. It doesn't even register a full volt. There you go, look. That's your power. So you can see your track's live all the time. And you can see it's changing all the time. So my red prongs on outside lane, my red's positive, black's negative. So if I change them over to prove it goes minus. So that means power's going through other lead, which puts it onto a minus. So that way around, that's your power output there. So your track's live all the time on digital. You set that to 2000 millivolts. That's how much. That's not even 1 volt. That's 0.008 of a volt. Now that track, each joint between your track has got to carry that voltage. So if it's loose, or if the track's loose, it's not going to carry it because you're going to have too much resistance in the track joint. If your track is dirty between your joints, it's not going to carry it. It's too dirty. It's going to increase resistance. Now that sort of voltage cannot send that much power through dirty joints and dirty rails. So if you want a reliable system and a reliable racing nights and stuff like that, you should always use jumper cables. On a small standard circuit in a set circuit that you buy, that's fine because you've not got many joints. But on my layout, with it being so big, I need to change that over. I need to put these jumper cables in. So the advantage of jumper cables, how they work is, because you're soldering a joint, you're soldering your cables, to your rails, there's no resistance there. And when you drop that down to your link cables and across to the far side of your layout and rejoin it in the same way, that means that the cable, the power runs through the cables as it's running through the track. So the electricity will always take the easiest route. So if you've got those cables in, it'll ping it across quicker to the other side of your track with the cables, and it would through all the joints in your track. So I'll just change the wires round, so my outside cable is going to be my yellow, then my inside cable is going to be my blue, because blue is a negative colour and brown is a positive colour, and then green's like an earth colour, so I'll use that for my negative with the rail, and then I can use the orange for alive. So I'll just put my camera here. So I'm going to get a bit of flux onto that joint like that. Get a bit of flux on the cable. The flux it's an acid. When you apply heat to it, it fizzes and cleans your metal. Like that, you can hear that fizz then. So, if I go crossways like that, so sheathing's going to the other side, so it will not, so it won't, it won't short it out. If I turn that, you can hear it hissing. So that'll get soldered onto it. I mean it's hot cable, it's hot, the heat transfers through it, so you can't leave it on your soldering iron on too long, because it'll melt your track. So that's one joint done. So what I've done is I've drilled the hole right where the rail sits. That's my lane 1, outside my lane 1's this side. I'll put my blue on that inside now. So what I want to be doing is fluxing my rail. You can see that's tucked to it better, that solder into this bit here. If you need to use lead core solder, because it's the best you can have. You don't want to be using lead free, because it won't flow. The solder won't flow. So but you always use flux, and you can use lead core solder as well. So you tin your wire. You don't breathe that in. Don't breathe that smoke in, because it's the acid off the rail. Acid out, the flux burning for you. So that's me line 1 done. You can see both cables are soldered to that now. Oh, look at that. So I had my wires right way around to start with. Pull them back out of there. So my yellow is the front cable. That's what I mean about making sure you flip your track right way so you don't get mixed up with your track. And then you use 2 different colours, 4 different colours, so you don't get your rails mixed up. We want from obviously not crossing power across, because when you go into analog, if you've got some old cars that you want to use on analog, you still need your rails to be separate. Right, so that's that one. So when you flip it over, you can see that the joins become separate. The joins are opposite way round. So I'll put my green where my blue on my blue side, and then I have my orange as my power. The Art Pro system does have a it's got a short circuit protector, so if you drop anything on the track, it will anything electrical conductor, it will shut off, so you don't actually damage your, so you don't in theory damage your start finish straight. This green wires, way the track runs, it runs over a brace underneath the baseboard, so it's just a little bit difficult to get wire through. Putting that wrong hole now anyway. So I'll just solder all these wires on this straight, and then I'll be back in a second. So that's all my cables soldered. Yellow and blue on one side, green and orange on the other side. So then my yellow's positive, my orange is positive, my green and my blue both negatives. So I'll just draw those wires down, and then I can connect this up. One other thing just to show you, this power straight's been in a while. It's been in a good few months. You can see the muck just here, right at the end of that peg, and same with that peg. So I'll clean that off. Then if you look on these, on the back side where the female side, on that inside there, I can tighten that up with my pliers, and same on all 4 rails, so it makes a really tight connection. So I'll just clean that off. So you've got to make that, if you make the connection tight, you're not going to be getting any resistance through your joint. And what we'll try and do here by doing all this is to lower the resistance, to stop the resistance from coming through. See how much tighter that is to connect that up, and that's what we want it tight. So I'll not connect that up now. I'll connect the power supply back up, and then you'll be able to see plastic pig light up. There you go. That one, and then that one. I'll show you a test meter on there as well. No, you can't see that test meter very well. I'll put these round onto my track, work this out. So there we go, 008 for that one. Then we'll come on to this other straight here, the one we just connected up. That's the same power. And the inside rail on there, the same. And that's the opposite way around, look. So the negatives on the inside, on the outside, on lane 2. So negatives are side to side, and the positives are on the outsides. So I'm going to swap them wires around now, that orange and that green. So when you do your negative for your test meter, your black wire to the outside, your red wire to the inside, that's showing that it's negative. That's power's going through test meter the wrong way. When you go do it that way, it's the right way. Then when you come to this side, that's positive, it's on the right side. Oh, you heard it buzz then when I shorted it out with test meter prong. There you go, look. So that's the fail safe that the Arc Pro has as a power base. I'll just swap those 2 cables over. I'm back in a sec. Right guys, so that's my track. I've not connected my power base in purposely. I've left it out so you can see it's not connected to any of my track system at all. So my track system is a very long way. So it's 6.5 meters. The back straight, I think it's 14.5 straights. I think the back straight. I can't remember exactly when I counted it last. So there's a lot of track in this. It's a very quick track, but there's a lot of track. It runs all the way around. So I'm going to go to the farthest point where that pit wall is, and I'm going to take my jumper cables to that, and I'm going to go crossways, halfway down. I'm going to crossways to the top of that hill, I think, and connect it up there to some jumper cables up there as well. So underneath my layout, there are my holes I've drilled with my 4 cables coming through. 4 cables coming through in baseboard there. I've screwed a tag strip on there, and then I've drilled my board with my cross beams through to there, through that one. Now I'm going to join up to that other tag strip just there, and go down to that chocolate block, connect to there, up to the other side, and then all the way through my baseboards. My baseboard constructions is 9mm ply with 2x1 timbers, like a ladder construction. So I've got those every few inch, every 8 or 10 inch I think it is, all the way down. So every one of my baseboards are all in this construction, and then they all split apart, and I've got bolts holding it together. So if I want to take it down, each baseboard comes down in sections. So there's 2 4-foot by 24 inch, 2 4-foot boards, and then 2 8-foot boards. I've widened this board. You can see me junction, me bit where I've widened it here. I've recycled these boards from the old layout that I've been expanding and changing all the time. So just so what I need to do now is I need to solder these orange onto here, onto that outside tag strip, then the green, then the blue, then the yellow. So I'll do that. Don't go away. Right, so that's those 4 colours there, the wires are soldered to that tag strip in order they are on the track. So positive, negative, negative, positive, and they've soldered that tag strip there so that they all stay apart from each other, and they won't bend and touch each other. So then the 4 thinner wires, I'll eventually cut them in half and put a plug in, and put 4 single plugs in on them cables, so I can take track out. So that's my wires are all routed. My wires are all routed through my board, like so, and then I can pull these through a little bit at a time. So now I can join these to this tag strip at this end, then through that chocolate block, and then I just need to put I need to get rid of these wires, cut them off. I can solder some wires to that. I've got all my boards, all my things to drill and send cables through, all from one side to next board to end. So I'll just solder that. I'll solder them onto that tag strip. I'll be back in a second. Right guys, so that's the jumper cables done. This is to me chocolate block and wires in the same order, up to my tag strip in the same order, through my baseboard to that other tag strip in the same order, and then up to the track. So with the so because it's on digital, both lanes alive all the time at that 008 volts. Just turn that power supply back on. See, that car just jumped then. So that is digital. Flick that little switch here. Now lights have gone out. You heard relay click. That's now analog. So turn green control on, because the green's on the on lane 2, and then you can see my lane 1 and lane 2. That's green. Put it onto lane 1. Nothing working because we're analog. So green don't work. Flick red controller on. Here. Completely dead. Pull trigger goes. And it goes. So that's on analog. So you can see no lights, no lights. Only lights up when you pull trigger on analog. So that's why we've done 4 separate colours and fitted it to the baseboard 4 separate lines, because there's 4 separate rails, 4 separate colours, and that's the road we've gone through there. So I've used 16 AWG wire on the actual cable that runs it from end to end, and I've used, so that's 16 on that cable, and then the jumper cable is 18. The higher the number, the thinner the wire, like the old drill bit sizes. The higher the number, the thinner the drill bit. So that's going to be it for this video, guys. Just done one baseboard. This is a 32-minute long video, and I've done it's probably took me an hour to solder all that lot up, drill my baseboards, drop my wires through, and do all that work that you can see there. So if you just look at the can look at the test meter there, and get me chuffing things properly. So put my test meter on track. Nothing. No power at all. When you, I don't know how I'm going to do this. Hang on a sec. So my system's on analog. No lights on car. I've got the lane 1 controller, the red control in my hand. I put that up there. You can see the track. So that's no power. Pull the trigger. Hang on, I need to change my setting on my test meter. So now we've gone to 20 volts now on my test meter. So when I go to full power, look at that, 15 volts. And that's wrong way around. Yeah, so that's that. Put car on track. That's because I'm pulling the controller. So that's it. Right, so if you watch the test meter and watch the car running, doesn't even register a volt to get car to move. on 20 volts. I flip that down to milliamps, millivolts, put power on track. Oh, it still didn't register out. Oh, it's not holding the frigging thing. I ain't got enough hands here to do this, I don't think. So I put that on. Yeah, it gives it full power, 15 volts straight away virtually, as soon as you pull the trigger. So what I've said, why I haven't gone thicker for my wires to my baseboards to end, because the thicker your wire, the thicker and shorter your wire, the less resistance that you've got for your power to run through. So meaning that if you've got like a 10mm thick bore cable and you're running power through that, it'll take so much resistance to force power through. Yeah, so the thicker the cable and the shorter the cable, the less resistance you're going to have. So that this cable I'm using on this silicon core multi-core cable will take a lot more. It will take loads of power to so that's woven its capabilities, and even that thinner stuff woven capabilities are taking power without causing any issues. So that's it for this video, guys. I'll get this wrapped up now. I'm going to get some dinner. I'll do another video of running my cables through and join up to the other end of my track. Thanks for watching, guys. See you on the next one.